Okay, everybody, I know nobody is here yet. I frankly don't know if anybody will show up, but there seems to be enough questions about how to perform NPV calculations and present value formulas in Excel um, versus the table, and just conceptually a lot of kind of confusion about some of the material. So I'm just going to go ahead and get started with homework 25, which actually was due a couple of days ago. So uh, so I'm just going to start with question number one, and we're just going to kind of go through it, and hopefully this is helpful in preparation for the exam that will be coming up in a couple of weeks, as well as your final quiz, um, or at least the quiz on this material, and then an application problem. So we're in the home stretch. Only a few more weeks left. Basically, 2 weeks left of material, and then the final week is the final exam. So after this homework number 25, um, and actually homework 26 is due today, you guys only have, I think, I was thinking like 3 more homework problems. 2 due next week and 1 due the following week. So we're getting real close to the end. Okay, so the first question. Again, my numbers are going to be different than your numbers. But the first question is the management company of operate company, a wholesale distributor of suntan products, is considering the purchase of a $26,000 machine. So the cost of the machine is $26,000. Okay, and that would reduce operating costs in its warehouse by $4,500 a year. So that's our annual cash, um, annual net cash inflow. And then at the end of the machine's 8-year useful life, so the machine's going to be good for 8 years. And the company's it has no scrap value, and the required rate of return is 11%. Is the rate of return. So here's some important information that we've got. And so the question is determine the net present value of the investment in the machine. Okay, so basically this is going to be fairly straightforward. We're going to use the present value formula. And in this case, 11% is our rate of return. And you know what? I'm actually going to expand this so you guys can kind of see the big screen. So this rate is going to be 11%. N per in Excel language is the number of periods. And in this case, we're talking 8 years. And we do have a payment. The payment here is $4,500. So just to help people understand the difference um, between receiving a payment every year, which is like an annuity, when you receive a regular cash flow, versus a one-time payment. If it's a one-time payment, we would put that amount in the fair value box. But in this case, since it is a reoccurring payment that happens every single year, you can expect it to come every single year. It's an annuity, then it's something that would go into the payment box. Okay, so in this case, we don't have anything in the future value that we're going to include. Okay, and you might ask yourself, well, what about type? Is it whether the payment's at the beginning of the period versus the end of the period? In this case, we're just going to assume the payment's at the end of the year in all cases because it does matter in terms of time value calculation. And in all the problems, you can just assume it's a type 0, that it's going to happen at the end of the period. And then click OK. So here we've got our net present value of basically, and we can make this negative, so it shows a positive amount, $23,157.55. Okay, so if this is our present value of those cash flows, and we are going to invest $26,000, okay, we need to know, well, what's the net present value? Because this 26,000 is the cash that we're going to put out right now. So if we're going to invest $26,000 today, we want to be able to make sure that we receive, at the very least, the same amount, if not more, at our required rate of return. And what this is saying is we won't. We will be receiving, based on our required rate of 11% over 8 years, we're going to receive in today's dollars $23,157, but we're investing $26,000, in which case we're basically losing value at the tune of $2,842. Okay, so this would be a no-go decision. We do not want to proceed with this investment. It wouldn't make any sense. So the second part of the question is, what is the difference between the total undiscounted cash flows and cash outflows over the entire life of the machine? Now, this is fairly simple. So in this case, all we're going to do is take the $4,500, multiply that times the 8. Okay, so that gives us $36,000. I'm going to go ahead and make that positive. So the total undiscounted cash flows is $36,000. Okay, so when they're undiscounted, we are going to receive an undiscounted cash more than the amount we're putting in. And it's to the tune of $10,000. Oops. Is equal to this minus that. So this is equal to the difference in undiscounted cash flows. Okay. So, looks like somebody may have joined. Who do we have? Karen Miller. All right. Let's see. Hi, Karen. How are you doing? I'm kind of in the middle. Thanks for coming. I'm just going over homework number 25, and I started with problem 1. So if that's okay with you, unless you have something specific you'd like to go over, I'm just going to go ahead and kind of continue, if that's all right with you. You just kind of let me know through the chat box. You don't have to connect audio if you don't want to. It's completely up to you. But at the very least, I'd like to communicate with you through the chat box. So anyway, so I'll just, as I wait for Karen to get back to me, I'm just going to continue. So that's problem number 1. So problem number 2 is, and I'm just going to label these, you guys. Problem number 1. Okay, so problem number 2. Looks like Karen is about ready to respond. Okay, so the Sharp company has $17,000 to invest, and the company is trying to decide between 2 alternative uses of the funds. So they both require $17,000. They've got project A and project B. Actually, I'm just going to go ahead and copy this. Okay. So we've got this information already in Excel. Okay. All right. So here we go. We've got 2 investments. These are the annual cash flows versus a single cash flow. They're both 12-year projects, and it looks like our discount rate is 17%. Okay, so the question is, which project would you do? Number 6, how do you rank the businesses? Are you talking about homework number 26, Karen? Yeah, okay, that's the next problem. Okay. Okay, let me finish up this problem number 2, and I'll switch to homework 26, if that's all right with you. Okay, this won't take very long. Okay. All right. So again, we're just going to do present value formula, and we'll just go ahead and expand the box again. So in this case, our rate is 17%. Our NPER is, I'm just going to type in 12 since I've got a word in there. That won't accept it. So our payment for project A, we get an annual cash flow of $6,000. Okay, and we'll go ahead and make that negative so we can show the positive discounted cash flow. Okay, so what did I miss here? I missed something. Doesn't like that. Okay. Well, That's not a real number. That's the problem. So let's put negative 6,000. Okay, so we've got $29,930.32 is the amount here. And then if you subtract the $17,000 investment, we get an NPV of $12,930. Then we've got for project B, okay, we're going to do a present value calculation again, same rate, okay, same 12 years. In this case, no payment. We've got a future value of $75,000. Okay, and again, we're going to make that negative, so we can kind of see the positive result. And that's only going to give us $11,398.06 in present value dollars. And if you subtract the $17,000 initial investment, that gives us a loss of value of $5,602. So clearly we would choose project A because that gives us the most value of the two. Okay? All right. So thanks, Karen, for being patient. So now let's move to, and just FYI, Karen, I probably have until about 12:30. So I think we should be able to get through your questions in the next 15 minutes or so, but I just wanted to give you a heads up that that's my time limit this afternoon, unfortunately, until, and then I'll be back on at 5 o'clock. So I know that may not necessarily work with your schedule, but I just wanted to give you a heads up, okay? All right, so let's go to question number 6, and how do you rank? So you're asking basically, how do you rank each of the projects? Is that right? With me, Karen? Let's put this homework number 25. We'll go to homework. I don't know what happened to Karen, but that's okay. We'll go ahead and proceed. Okay, she's probably listening, eating lunch or something. Okay, so here we've got Austin Company. They're investigating 4 different investment opportunities. The information on the 4 projects is the following. So we've got 4 projects. I'm going to go ahead and copy and paste that information up here. So it can be seen. Those are the projects numbers. Okay, let's erase this. It's a little more presentable. Let's see, that's, you know, sometimes copying doesn't always lend itself perfectly. Project 2. Let's go and erase these columns because we've got some extra columns we don't need, just so we can see this better. That's project 3. And we're going to erase this. And that's project 4. Okay. We have everything. We've got internal rate of return. We've got the life of the projects, the net present value, the present value cash flows, and that's okay. So got all the information for this problem. Okay. So the first one is compute the project profitability index for each of the investments. And then their discount rate is 12%. Okay. So first, the project profitability index. So this is in your book, profitability index. Okay, but it's a pretty simple equation. It's just your net present value divided by the investment required. Okay, so we're going to go ahead and here's our equation. Okay, so if that's the equation for project 1, we're just going to do this we'll calculate the project profitability index equation. Okay, so we're just going to take our NPV, which they've calculated for us. Okay, and we're going to divide it, whoops, not equals, divide that by the investment required, which in this case is the 740,000. And of course, these aren't truly numbers, so my little formula here is not going to work perfectly for me. So let's just kind of make some adjustments to these so we can actually use them. Okay. Okay. So this gives us a project profitability index of 0.3035. Okay. And then for project number 2, by that, that's point. And I think it asks you to round to the nearest 3 decimal places. So there's 3, and there's 3. And then there's project number 4, or project number 3, excuse me, 0.042. And then we've got this one. Okay, 0.068. All right. So now the question is, how do you rank the 4 projects? So it's all going to be different based upon which criteria we're using, right? So I'm going to color code these, right? So I'm going to say 1. I'm going to say anyone with a ranking of 1 should be green, right? Because you're going to green light that. The second ranking we're going to say is just a light, is green also, but just a different color green, right? And then because it's a project that you most likely would pursue, but possibly not, 3 would be a yellow, and then we'll just go ahead and say that 4 is a red. Okay, so that way you guys can kind of see how we should rank these. So based upon the first criteria they asked is based on net present value. So in this case, you're just going to look at, well, which net present value is the highest? Okay, so project number 2 is the net present value that has the highest number. Then project number 4 is the second one. Okay, and then the next one would be project number 3, so that gets a yellow. And then oh wait, no, I'm sorry, I mixed that up. Sorry, that should be the red. And then project number 1 would be the yellow. Okay, so that's ranked 3rd. Okay, all right. So that's net present value. The next one is the project profitability index. So now you're going to go down to your project profitability index calculations. And again, in this case, the one with the highest index is the one that you're going to use. So again, it's project number 2. Then the next highest in this case would be project number 4. Okay. After that is project number 3. And after that, project number 1. So as you can see, based on the 2 different criteria, the first 2 projects fell in the same ranking. The second 2 swapped, right? And this is real life, because your projects aren't going to be, it's not going to be clear across the board necessarily using all these different criteria which ones you should pursue. Hopefully you have at least 1 or 2 that float up to the top like this, that more or less meet the top, are in the top rankings of at least most of the criteria, but none of them are ever going to be most likely the top in all the criteria. And you're going to have many of them that will end up swapping places back and forth depending upon the criteria that you use. Okay, Karen, you're saying that is what you tried, but it marked them wrong. Okay, so let me finish the internal rate of return one, and then we can go to your specific problem. So internal rate of return, again, you want the highest internal rate of return. So in this case, we've got the project number 4 is the highest, and then project number 2 is the next highest. Project number 3 is the one highest after that, and then project number 1. So in this case, if you look at project number 1, it's red in 2 out of the 3. So project number 1 probably isn't the right way to go. Project number 2 clearly is a project that's worth pursuing, as is project number 4. Project number 3 is maybe. In theory, anything that gives you an internal rate of return higher than your discount rate is one you'll want to select. So in theory, you would select all 4 of them because they all give you a higher internal rate of return than your discount rate. But again, you might have other criteria in terms of maybe you want a net present value of something greater than 25,000 or a profitability index greater than 0.05, for example. So anyway, you might have other criteria. But Karen, let's take a look at your specific problem. So let me go to your assignment. And I will not show it to the rest of the class. Fortunately, I've got another screen. So let's pull yours up. This will be boring this is like radio, right? Nobody can see what I'm doing behind the scenes. So I gotta talk to entertain everybody. I wish I had a good joke I could tell you. All right, let's go to assignments in progress. Homework 26. Let's go to question 6. And let's take a look here. So, Karen, you've got your net present value. Aha. Yeah, see, so your first preference, Karen, you went the lowest first. So you chose, for example, on your problem, the project with the highest net present value is project 2. You chose project 3 as your first preference. And project 3 actually has the lowest net present value. So with net present value, you want to go with the highest. That would be your first preference. Your first preference is always the project with the highest net present value. It's always going to be the project with the highest project profitability index and the one with the highest internal rate of return. I think you have them upside down. Let's take a look at what Karen's typing. Typing something furiously, I can tell. I can tell she's typing something furiously. Or maybe not. Well, while she's sending out a message, I will upload this. I did not. We're approaching 12:30, but I did not finish homework number 25. But I will continue that. I only got through the first couple of problems, but I will continue that at 5 o'clock Pacific time. So if anybody can join at 5 o'clock. Yes, I did read it wrong. I thought I was supposed to rank it by order as a number 1. No, so number 1, you're just calculating the profitability index. That's not a ranking. Are you talking number 1, part 1 of question 6? Because that's not a ranking. That's just a calculation. So I apologize. Yeah, that's okay. Yeah, so fortunately you haven't submitted it yet, so you have an opportunity to fix it, and you should be good to go. So any other questions, Karen? Okay, no problem. Okay, so everybody else, I'm going to go ahead and stop this office hour for now because we're about 5 minutes away from 12:30. But I will be available again at 5 o'clock. And in the meantime, this afternoon, I will post this recording for anybody that that wants to hear it. Did you do the 4th one correctly? The 4th. Fourth problem. Fourth problem. So question number 4. 1, 2, 3, 4. Let's go back to that. The one about payback periods? Yes, you got that one correct. You got the fourth one right and the fifth one. You are welcome, Karen. Okay, Karen, do you have any other questions? Okay, great. And Karen, do you mind you being part of this recording at all? I just want to make sure. Nope. Okay, great. All right. Well, thanks for coming, Karen, and everybody else. I will post this as well as this spreadsheet, and anybody else can then join at 5 o'clock. We'll see you then. All right. Thanks a lot. Bye, Karen.